Hi, this is Jagdish, Assistant Professor of EC Department, SNS College of Technology. Today, we are going to see the next topic in our video lecture series, Artificial Intelligence and Machine Learning. So, the topic name is Weight Space and Curves of Dimensionality. Come, let's get into the topic. So, first, let us start with weight space. So, what is weight space in machine learning? So, weight space, that is a representation theory. It is a parameter space in artificial neural network where the parameters are weights on a graph edges. So weight represents the strength of the connection between the units. A weight may bring down the importance of an input value or it may elevate. So this is actually a weight space. So let us see this diagram, this illustration, so you can understand in a better way. So here in the left side, you can see the one dog. So dog image is there. Actually, it covers almost up to the neck. So the face is covered fully. And here the each part in the dog face is dissected, that is separated. See, you can see the eyes and you can see the ear like that, right? So this each part which is given as one weightage because what the reason behind this means when you are training the model machine learning model, right? The model must understand the object, I mean object or any person's that I mean the face or anything, right? So that must be trained to the machine learning model. Here the dog, so the dog face it will be similar to all the dogs, right? So only some features, some dog may have a bigger ear and some rounded eyes like that. So some unique feature is there. That unique feature must be given the values, must be the weight value must be increased to higher value, so that the model can be trained and it will predict the predict the input test signal, I mean test input accurately. So this is the significant importance of the weight space. So here you can see the dissected that model, that is images which is given to the different weights, and finally the dog will be predicted. Okay, if you given the image or any dog in front of the camera of your model, right, it will predict it is a dog. So this is the importance of the weight space. So this only I have told you, right? So each the separated images from the dog face, which is given as some value 0.2. For example, that is a your I mean the eye value which is given as 0.2. The nose value is given as 0.6. Here the ear value which is given as 0.2. So here why we are giving as 0.6 means for no for nose. This dog has a some unique I mean, shape, different, like slightly different nose compared to the other dogs. So we are giving 0.6 weight for the nose alone. So altogether, when you summation the all the values 0.2, 0.6, 0.2, what will be the value? Final value will be 1. So the weight space value will be 1. But the thing behind is which parameter, which in image, which part which is given as a higher weightage, we have to give the value accordingly. So let us see the classroom activity. It is a rebus puzzle. You can see, tell the answer for these, illustrations. For example, I will tell you the second image, right? The second box here, get it, get it, get it. 4 get it in a vertical manner that is represented here. That means that from this, what you have understood that you have to tell. So here, that is something we have 4 get it. So that means 4 get it. When you combine these two words, what you will the sentence will be framed like forgot it, like that. So like that you have to understand, you have to observe the thing in the image, and you have to tell the answer for each box. And the next topic is curse of dimensionality. So you know what is curse? So curse is you could have heard this word curse in many movies on the in olden day movies and all, right? The saint or any kind of I mean spiritual real spiritual related person used this word curse. So that means for a best example, any I mean saint. Who is sitting and doing meditation in the I mean deep forest, and some other person, any other person, is disturbing that saint. The meditation means at the time the saint will get angry and immediately he will do the curse. Like you go like a dog, you go like a monkey, you became like a donkey like that. So this is actually a curse. So this curse of dimensionality, how this curse is related with your machine learning, that we will see. Okay. So the curse of dimensionality is nothing but of, actually here the first thing we must understand is the dimensionality is nothing but of a features. Okay, so the curse of dimensionality in a machine learning arises when working with a high dimensional data, leading to increased computational complexity, overfitting, and spurious correlations. The technique like dimensionality reduction, feature selection, and careful model design are essential for mitigating its effects, improving algorithm performance. The curse of dimensionality refers to the phenomena where the efficiency and the effective algorithm detroit as a dimensionality of a data increases exponentially. So the higher dimension spaces, data points become sparse, making it challenging to discern meaningful patterns or relationship due to the vast amount of data required to the adequate sample of space. So if you increase from this, what we have understood this, if you increase the features, number of features, that means dimension, that itself give the problem to the machine learning, right? So because um, more number of features will not I mean advisable to train the model. And you can see the image, right? The house price. So the house price is nothing but of it is I mean that will be defined by the some features, like the size of the room, number of room, location, right? So these things, these three things, which is called as features. So features, I already told, the feature is nothing but of a dimension. So after threshold, the model will not give a much higher accuracy. See here, we have three features. If you increase the features again more and more, then what will happen after after some threshold, right? If you increase the feature or dimension, what will happen? The model will not give the accurate output. This is the concept behind of the curse of dimensionality. Even though we have a number of dimensions, so that will not be if it exceeds the limit, then that will be a curse for the machine model. So how to overcome the curse of dimensional limits? That is, first thing is feature selection, then features extraction. These are all the some methods to overcome the curse of dimensionality. So let us come for the assessment. You know, now you understand what is weight space and what is curse of dimensionality. So now for you the assessment is, you have to describe the real-time example for the curse of dimensionality concept. So with respect to the curse of dimensionality, you have to give the real-time example to explain the curse of dimensionality. This is the assessment question. Thank you.